continuing with solving radical equations. All right, so we did yesterday. Oh, we don't have the one from yesterday. But those ones we did complete yesterday, so you had to isolate the radical term, then square both sides. Same thing here. If you do have two radical terms, though, you're going to have to perhaps do a square of both sides twice. First one, the radical term is by itself, so it's all good. We just square both sides. See if I can reach it. Okay, so squaring a square root just gets rid of the radical sign. When you square the right side, make sure that you square that correctly. Remember, I get a gray hair every time someone gives me x squared plus 4. All right, so it is not x squared plus 4. It's x squared plus 4x plus 4. Okay, so now we get x terms together. I'm going to bring them to be positive, so I'm going to add x squared to both sides. So that'll be 2x squared. 4x's go to 0, and this goes to 0. So it's really 2x squared equals 0. Solve that. Okay, so we get x equals 0. Then you want to see, does that make sense, right? So you verify. So square root of negative 0 squared plus 4 times 0 plus 4 is the root of 4, which is 2. And the right side, 0 plus 2 equals 2. And you can verify graphically by graphing the left side, graphing the right side, or graphing everything on one side and seeing where it crosses the x-axis. Next one, there's one radical term, so we need to get the radical term by itself. So we're going to subtract 2. So this will be x minus 2 equals root of x plus 10. Square both sides. Solve for x. Really what you want, another way of verifying, is to look at the values of x that are defined in the equation. This one's a little bit harder. If we're finding the values of x that are defined, we have to, basically that's a quadratic that has to be greater than or equal to 0. So we'd have to use the methods from the last unit, either graph it or case analysis to do that. So that's why it's easier just to verify that solution and make sure it works. This one's pretty straightforward though. When we get our solution, we know that x has to be greater than negative 10, right? You can't take a root of a negative. So you could look at that. Again, the way I do it, I just verify, okay? It's easier as long as you do your math correctly, okay? Then it's kind of easier to do it. So we're going to square both sides. If you squared this right away, you'd have two terms and you'd still have a radical, so you'd have to square again. So easier to get radical by itself, and then there's only possibility of introducing an extraneous solution once, rather than each time you square it, there is a possibility of introducing an extraneous solution. So again, squaring this has 3 terms. Squaring the right side, the radical goes away. Now it's a quadratic, so get everything on one side. Okay, and then that we can factor. So factors of negative 6 are negative 6 and 1 that add to negative 5. Okay. So this is where, if you are looking at what values of x are defined in the equation, x has to be greater than or equal to negative 10. Okay? So both of these are, but do both work, right? So negative 1, we'll have to check when x equals negative 1. And I go back to the original form, in case I made a mistake rearranging. So this is when x equals negative 1. X is negative 1 here. Negative 1 plus 10 plus 2. So you'll notice that that doesn't work. So left side is not equal to the right side. So that's extraneous. Okay, then you do the same for the next one, for x equals 6. So 6 on the left, 6 plus 10 square rooted plus 2. That one does work. Okay, so then I go back and I rewrite with just the solutions. Okay. So looking at the domain didn't find extraneous for us. Reason being, if there was no, if there isn't another term with x in it, then you can just look at this. But there is anything higher than degree 1 or higher of terms outside the radical, then you do have to verify. Okay. Next one has 2 radical terms. You could square both sides right now, but it'd be kind of complicated. Okay, you'd still have a radical. So I always suggest, even if there's no other terms, to get 1 radical on each side to start. So this is subtracting. So that means I'm going to move this over just to make it positive, right? So root of 2x plus 6 on the left. 3 root x minus 4 on the right. And then square both sides. Okay? Biggest thing to remember is not to forget about the 3. You have to square that whole thing. So here, left side squared, right side squared. And then squaring a square root just gets rid of the radical sign. Squaring this makes that 9, and then bracket x minus 4. Right, gets rid of the radical. Okay, so now no radicals, we can expand the brackets. It's just a linear equation. And solve for x. So I'm going to bring the 2x over here, that's 7x. 36 over here is 45. So x, not 45, 42. So x equals 6. Okay, and then you want to check. Okay. Go back to the original in case you made a mistake. simplify each radical. You're going to need to simplify root 18 before you can subtract anything. So that's 3 root 2 minus 3 root 2, which is 0. Now this one didn't have any other terms with x in it. The x's were all underneath the radical sign. In terms of checking what values of x are defined in this, so let me do it in green here. From this one here, x has to be greater than or equal to -3. Right? This whole thing has to be greater than or equal to 0, so bring the 6 over and divide by 2. This one, x has to be greater than 4, greater than or equal to 4. So it's the overlap of those, right? So the x values that are defined in the whole equation, no matter what you put in there, if this was a function, okay, what would it be defined for? Has to be satisfying both of these. So this one wins, right? Because if we said, let's say x is 0, so 0 is greater than -3. If I put 0 in here, I get a negative, so it wouldn't work. So for sure, when we get our solution here, it has to be greater than or equal to 4. Not even an option. Okay? Could be anything else. Then for f, has 2 radicals and another term. So again, same as this one, get a radical on each side. Makes it a little bit easier in terms of squaring both sides. Okay, you can square it both sides there, but it's more complicated. Okay, so here, I'm just going to bring this term to the right. So this is going to be root 4x plus 5 equals 2 plus root 2x minus 1. Okay, a radical on both sides. We're never going to give you one with 3 radicals. Okay, then square both sides. Biggest thing to remember here is this is 2 terms. So when you square this right side, you get 3 terms. First term squared, product of the 2 terms doubled, last term squared. So first term squared, product of these 2 terms is 2 root 2x minus 1. Doubled is 4 root 2x minus 1. And then the last term squared just gets rid of the radical sign. So you can show it as 2x minus 1. I put brackets around it, but you don't have to because it's adding. Now when you look at it, there's still a radical term. So get everything else on the other side. So when I bring the 2x over, that's going to be 2x. When I bring the 4 and the minus 1, that's really 4 minus 1 is 3. Bringing it over will be worth 2. You could divide by 4, both sides, but then you'll have a fraction on the left. You could divide by 2 both sides. That might be good, but you don't really have to, because then you'll still have a number in front anyway. Okay, so you don't have to divide by 2 here. We'll end up dividing at the end. So now, we'll square both sides. And again, we have 4 terms, so 3 terms. 4x squared plus 8x plus 4 on the left. 16 times 2x minus 1 on the right. Expand the brackets. It's quadratic, so get everything on one side. Okay, and now we can divide by 4. And then here we can factor that. X minus 5 times x minus 1. And then verify for this. So 4x plus 5. Okay, so x equals 1 works. Oh, I put in 2. It's 5. So that's 25. Okay, and that one works. So those are your solutions. If you are wanting to check algebraically, so I don't have my calculator out. Give me a sec here. Okay, so we would go back to the original and enter on y equals. Up to you. I'm going to put everything on one side. So square root of 4x plus 5. I've got to close the brackets on mine, minus the square root of 2x minus 1. Close that bracket, minus 2, and graph on a standard screen, because we think the solutions would fit on there anyway. Kind of hard to see, so we're going to go, actually, whether you need to see it or not, we think our solutions are 1 and 5. Oops, sorry. So, trace 1, enter, and we get y equals 0, so that works. And then trace 5, enter, and we get 5 equals 0, or y equals 0. Okay, so can't really see much of the graph. If you change your window, let's go from 0 to 10, and from like -2 to +2 for y, because we really only care what happens on the x-axis, then you can see it better. Okay. Oops. All right. Okay. So that's it for radical functions.